So, good morning, my dear students. Let us now continue chasing victory with the continuation of our lesson this morning. Are you ready, my dear students? Are you excited for a fun learning session? Well, shout out to Canva for this awesome template. Before we begin, please make sure that you have the following. You have your pen and paper, your calculator, which can be also your smartphone with scientific mode, our Phet simulation on vector addition, which can run through your laptop, tablet, or smartphone. Okay, so let us claim victory. To begin, let us have a short review of our previous lesson. So what can you say about these two pictures? That's right. These are the two methods used in order to determine the resultant of vectors. So first, what do we call this method? You can write them on your paper, write it on your paper, or you can comment on the chat box below. That's right. We have the application of the Pythagorean theorem when two vectors form right-angled triangles. How about the second one? Again, you are correct. So we have the polygon or the tip-tail method. So this is used when three or more vectors will form polygons that do not form right-angled triangle. Okay? So, very good, my dear students. Now, are you ready to learn the third method of adding vectors? Well, sit back and relax as we proceed with the third and the most versatile way of finding resultant vectors, and that is using components of the given vectors. Now, based on the picture on the presentation, how do you describe a component of a vector? Okay, very good. In a two-dimensional coordinate system, any vector can be broken down into its x and y components. So meaning, this vector A here with a magnitude of 20.6 and an angle of 50.9 is actually a resultant vector of two vectors with a magnitude of 13 and the other with a magnitude of 16. Okay? Now if you break down vector A, this 13 here is actually the x component and 16 here is the y component. Okay, so why is that? So well, we can find these values later on as we go through our lesson. So if you have questions later on, just comment down below, or you can direct message me so that I can recognize your queries. Before we proceed, let us have to take note the different or the two rules that we have. The first, the vector and its components form a right-angled triangle as shown below. However, we can also plot it such that the x component coincides the x-axis and the y component coincides with the y-axis. Well, that's the reason why they are called x components and y components. Okay, because they coincide with the different axes. Okay, next, to have uniformity, we use the angle between the vector and the axis, x-axis, especially when the direction is given. Okay, for example, on this picture, vector A has a magnitude of 12.2 and the angle is 35 degrees. Now this angle 35 degrees is between the vector and the x-axis. Okay, we will use this angle in order to determine the y component and the x component. The second picture below uses a real direction. So we have 45 degrees northwest. Now, in order to conform with the first rule, wherein the vector and its components form a right angle triangle, we need to actually use this 45 degrees as the angle between the vector and the x-axis. However, the simulation that we will use will present the supplement of this angle, which is 135 degrees. Okay, now please do take note of that. So we have to use this angle in order to conform with the first, but it does not mean that 135 here will give a wrong answer. No, it will still give a correct answer. However, in order to avoid confusion later on, we will use the angle between the vector and the negative x-axis so that it will create a right angled triangle. Okay, so do you have any questions? Let's proceed. The activity for this morning talks about the components of the different vectors. So we have here the interface of our Phet simulation. We have here the different panels and toggles. So we have here the graphing paper. We have here panel 2 is where we can get our vector. Then panel 3 here are the attributes of our given vector. So the first procedure is to drag a vector and then plot it on the graphing paper. Take note that we are not using the tip-tail method in order to determine the resultant vector. Therefore, we will only have one origin, and that is the origin of our coordinate system. So all of our vectors should originate from the origin of our coordinate system. Is that clear? Right. Now, after dragging the vector on our graphing paper, we have to take note of the magnitude and the angle between the vector and the x-axis, and then record them on the table on the next slide. As well, we have to determine and record the x and y components of the vector and be written on the columns 4 and 5 respectively. Okay, let's see the table. So we have here the table. Vector 1 is already done, and I will give you that as an example. And vectors B to E will be plot by you, my dear students. Okay, so you have to write down on your paper as we plot the different vectors, the x and the y components. If you have questions, you can just type them on the comment box and we will consider those questions. Now, let us proceed to our Phet simulation. So I will just escape this presentation and then add tab, then type in Phet. Okay. So let's just wait. The internet is somehow slow. So this simulation is written on HTML5. Therefore, you may not install it because it can run natively on our browsers, even on your cell phones or tablets. So you just play the simulation and it will proceed to the simulation itself. Okay, let's just wait because the internet is somehow slow. Okay, now let us explore the lab part of vector addition. So we will click lab and there you go. So we have here our interface. So let's drag this at the center because we will only use one origin. And then now let us plot our table. So we have here our values, the magnitude and the direction of our vectors. So let's see the first one. So let's plot the first one. So let's drag the vector here and then drop it on the origin. So see, you can see that since this vector is selected, we can see the attributes of this vector, and that has been written on the table. Okay, the x component is 8 and the y component is 6. Yeah, it's easy as that. Now if you will add another vector, you can drag another vector from the panel here and then drop it on the origin and use our mouse in order to find the exact magnitude and exact direction. So you can just pull it like this in order to get the exact magnitude and then the direction. Take note that we are not using the tip tail, wherein we will put it like this. Okay, we are using the component method. There you go. Okay, so I will give you 5 minutes in order to complete the table on our presentation. So please write this down on your paper. Okay, time's up. Let us now see your plot. So I have here a predetermined plot that I already created a while back. Okay, so if your plot or your graph looks like this, then you are victorious. Otherwise, try harder next time. Okay, what do you notice on the different vectors? That's right, so they all form right angled triangles, but we can toggle on this switch here so that all components will lie on the x and y axis. So let's see, there you go. That's the most important part of using the component method. Why? Because we are actually adding algebraically the different x and y components. So notice that if you will add all the x components, we will have what value? That's right, so we will have a negative value. So we expect a negative value. The same as true with the y component. So if we will add all of these components, then notice that we have a longer negative y component value. Therefore, we will have a negative value on the sum of the different x or the y components. Let us see. Okay, let's go back. So on our presentation, the table will look like this. The sum of the x component is negative 13 and the sum of our y component is negative 7. Now we will use these values in order to determine the magnitude and the direction of our resultant vector. So how do we do that? Well, we can use, of course, our Phet simulation, and this dark line here will tell us the resultant vector, and these are our x and y components. However, what if we do not have our Phet simulation? So how do we add vectors through the use of components? Okay, so you may write your answers on your paper. You are given some time to do that. Now, you are actually correct, because in order to determine the magnitude, we add all the x and y components algebraically and then use or apply the Pythagorean theorem on the sum of the components. In short, we go back to our first method. We just use the x components and the y components to simplify a right angle triangle. And to determine, of course, the direction, we also apply the trigonometric function just like what we used in our previous method, which is the inverse tangent of the y, the sum of the y components over the sum of the x components. So do you have any questions on that? We will not elaborate on this because we have already finished discussing these methods on our previous lesson. But the real question now is, how do we determine, using mathematical calculations without any Phet simulations, the x and y components of each vector, and of course finding the magnitude and direction of the resultant vector? This question will be answered after our break. So you are given 10 to 15 minutes to finish your personal necessities and then go back as we discuss this question.